Okay, hello everybody. Um, Today I'm just going to show you the z-axis of my CNC machine. And I know there's a lot of guys out there, there's a lot of build out there, and everybody's showing what they've done. And there's a lot of guys out there that wonder how they're going to do it and thinking about methods. And I can say it's just easier to go and buy a z-axis with all the sliders and even the motor already attached. The z-axis I've built you can never think of everything all the time. You might do something and later on you might go back and you might make something better. Make it maybe out of metal, maybe insert a bearing or whatever comes up in your mind. So if you're in the process of building a z-axis or thinking of how you're going to do it, then just know that you're not going to do it correctly from the start. Now this one I've got here is evolved, let me say that, over the years. And initially what I had on my machine was really it was really crap, but it worked. It just wasn't as efficient and as good as it could have been. Now I'm just gonna, this is the z-axis. I've upgraded this one, and this is what I have at the moment. I'm gonna show you now what upgrade I've done. Now I'm just gonna move the camera so it's to the side. I just want to actually show you the piece of aluminum I've got. Now this aluminum was, and you can see I've got one long beam running across, and it's exactly the same as this piece. This piece actually was a cut-off when I bought this because this was too long. And this part actually they cut this off, and I think it's 300 millimeters long, and it was perfect for my z-axis. So now I want to show you. So all I did, I put my sliders on here. I mean, it's pretty straightforward. Everybody's done this probably while we're building a z-axis, and we know there's different kinds of sliders. These ones are the most accurate, but you can really use anything you want. Now this piece of aluminum I've got here, I mold out on my manual lathe. I did it manually on my lathe, and it's not the most accurate because the lathe is also not the most accurate. It's really a Chinese lathe, so it is what it is. So originally what I had was a normal threaded rod like this one, and I mean you can buy this from any hardware store, and this is really just a long nut, and it's, I mean, you just want to see, and you can see here's a standard nut. So this is really just a couple of nuts all, and I mean originally this is what I had a couple of these on here, but then I thought about this. So what I had in here originally, I mean this cavity was molded out, and this long nut, I think I had two of them, would go right in there, and the other one at the bottom. And all I had this standard threaded rod. I mean, I still have my holes on the side, and it would just run through. And I didn't really know how I was gonna make this thing to not move around in there, or sideways, or up and down. So I was actually very lucky. The depth of the cavity in here was slightly less than the thickness of this, which meant it was standing out at the top. And like I said before, this piece of, if you can call it engineering, you see evolved over time. I didn't just do it right from the beginning. But like I said, that nut was slightly standing upwards. And just remember, I had two in there, so it was filling it up. And this plate, this is really just a spacer plate that goes on top here, would make it level with my, what do you call these, pillow blocks. It would be level. This is the gap size. It looks like about 1 millimeter. And I just didn't want to pull the whole thing up. I just put the spacer in there. And when I had this thing bolted down, it would actually push this nut tight. It would lock it down. And yeah, so my problem I thought I was going to have is it was going to move in there, but it worked out well. This didn't move. I never had any problems when I was milling with a machine this way. So this is one method. If you're in a budget, you can start out like this by using standard cheap stuff you can buy from your local hardware store. And like I said, that's worked fine for me. And also at the bottom here, you can see, obviously in your case, there's things you're going to have to try and figure out. But previously I had a piece of wood at the bottom with a bearing that was holding the whole Z-axis up. And this was the only thing that prevented the Z-axis from falling out. And you must remember, on here I've got a 1.5 kilowatt motor, which is quite heavy. So just, I'm mentioning this just to show you that this piece of wood actually, it held up fine. I mean, it's just wood, but it worked fantastic. It never came loose. And you'll see now, because I've got a new I'm just going to call it threaded rod in here. Obviously now I had time to upgrade this wooden part, and I found a piece of aluminum actually in my aluminum scrap box, which I repurposed. And I've got a bearing in there, and I've got a collar in there, and this prevents the Z-axis from falling out. The motor which will drive it, the stepper motor, will keep it from being pushed up. So all of that is sorted out. So yeah, reason being for my upgrade, at the time it was cheap, but also a threaded rod and a proper rod, there's a big difference. And the time it takes to climb out of a cavity after it's finished milling it, in my case for a 60 millimeter, it would take like 3 seconds, because the threaded rod takes a long time to move your Z-axis. And like I said, the reason for my upgrade was, in this case, it's going to lift it. I think it'll take a second, because your angle of your threads. And this is the proper thing that you use for it. It's just, yeah. So, and also again, in my case, this was not expensive. I bought 2 of them, because when you buy one, you only get 1 nut. And 1 nut to move the weight I've got on here was I think it's a little light for it. So I bought 2 rods to get another nut. And I'm just going to take this out, and you can see it's a brass nut. One is there, and I've got the other one sitting here now. The nut is round, so again, you just file it down and you push it in there till it fits. And you'll see in here I've got a spacer, and the spacer is, I don't want to use the word exactly, but it's it fits tight, so it pushes the two nuts apart. So it acts as one, because if the axis is, I mean, in most cases it will be hanging, so it will be resting on this nut. And this nut won't be doing any work, not even when it's pushing up or pushing down. It will just be here, because there's no, it's, how can I say it, if it was on this side, it would work. But I've put everything inside and I've put a lot of grease in here. So the only way to make them work as one unit is to put in a spacer, and I've got this spacer on top and I've got another one at the bottom, and it pushes them apart. And I've got a spacer in here and another spacer at the end there, and the whole thing is tight. It doesn't move, but it still moves freely like that. So that is what I came up with, and I'm sure it's going to work fine. Time will tell. So like I said before, your Z-axis will probably evolve over time. You'll find better methods, but this is just to show you what I have done and how and what is working for me at the moment. If you don't want to go through all the work, you can buy a complete Z-axis, and I mean, they're expensive. Other thing I want to point out, I've got a lot of holes here, and I've got this that goes on top here, and I've got another one that goes at the bottom here. And these big nuts, screws, I've got another two on the bottom side. They hold, obviously, I'm not sure I'm close to the camera, they will hold the clamp for the mill. So yeah, I really hope somebody can maybe use what I've done here, or maybe get them a better idea how to build the Z-axis. Yeah, so don't think you're going to do it right the first time. It will evolve, and you always find better ways to clamp things or hold things or to make them move. All right, thank you everybody. I really hope this was useful. Cheers.